Okay, so Díomh Gwiniushla tá fáilte romh go léir go dtí an féile AtlanTec. Good morning, good afternoon, good evening, everyone, depending on where in the world you're dialing in from. I'd like to welcome each and every one of you to today's cybersecurity session at the festival. As most of you probably know at this stage, this is the 7th year of the festival, and it has gone from strength to strength over that time. I'd very much like to thank the organizers and all the sponsors for putting together another excellent program this year. It's a packed week so far, and there's lots more to come over the course of the week. There's 40 events scheduled with over 60 speakers. And I hope that all of you are learning as much as I have learned from all of these sessions. Despite the virtual format this year, we'd love for all of you to get engaged with today's session. So please do use the Q&A and the chat functions to get involved. There's the Q&A function is, if you look at the 3 dots down in the the bottom right hand corner of the WebEx, you'll find the Q&A function there. So please do use that for any questions, or use the chat to get involved as well, and we will have an audience poll as we're going through the session as well. For any of you on social media, you can follow us on Twitter using @AtlanTecFest and use the hashtag AtlanTec. For those of you who are not familiar with AtlanTec, we're a community of technologists, and we're based here along Ireland's Atlantic seaboard. Today we're basking in the glorious sunshine of the calm before the storm. And this has become a technology hub, which we like to refer to as Europe's Atlantic Gateway. My name is John Barry. I'm based at Intel's Networking Research Center in Shannon, and it's a great privilege to be able to moderate the session today. I think recent events here in Ireland are very much brought home to everyone the critical importance that cybersecurity plays now in all of our lives, and very much sort of reinforces the message that all our systems and networks, no matter how benign or benevolent their application, can come under attack, and can be targeted by cyber criminals. So hopefully, the sessions this week will allow us to learn a lot around how we prevent these attacks. And today's speaker is a colleague of mine, Marek Zmuda. Marek has a PhD from the Gdansk University of Technology in Poland. He's a security architect now for a long number of years at Intel, based in Gdansk in Poland. His areas of research are primarily around the security of firmware and embedded systems. And today's presentation will cover the concept of a secure development lifecycle. It's becoming more and more important for all of our systems, no matter where they'll be deployed, to have security designed in from the ground up, not added as a an afterthought afterwards. So Marek will provide a number of insights around creating development organizations where security is an integral part of the entire design lifecycle. So as we're getting going, we'd appreciate if you can pop any comments you have in the chat. In particular, we'd love to hear why this topic is of interest to you, and what are the elements of a secure product lifecycle which are important or which resonate with you and your organization. So without further ado, I'll hand over to Marek, and we can kick off the session proper. Marek, over to you.
Thanks for inviting, and thanks for nice introduction. Can you see my screen?
Yep, I can see it now.
Yeah. So hello everybody. I'm really happy to be here with you and be a part of this great initiative and a great conference. I'm also happy that all of you are interested in the security related topics. Security becomes more and more important. So my name is Marek Zmuda. I'm system security architect. I'm working at Intel in our development center in Gdańsk. My main focus is on the whole system based on SoC security. So I'm responsible for the hardware security, firmware security, and software security, and all the interactions between those components. So It's really interesting and exciting rule for me. And I would like to, during this presentation, share some learnings that I did from the time when I started with the security that are wide to the, I think it applies to the old technologies. And I would like to convince you during this presentation that it's really worth to think and consider all the security requirements from the beginning of the project. Here is the disclaimer that is required by the law. We will run the Q&A session on the chat during my presentation. But please be informed that because of my position, I'm not allowed to answer any questions that are related to the Intel product security. So if you have any, you need to use the official channels to get an answer. During this presentation, I would like to start this presentation with building the common understanding. What does it mean that the system is secure, is protected? Then I will introduce the security by design concept that is crucial for today's product development. We will talk also about the activities that is performed by the hackers, how they are finding vulnerabilities, what they are doing, because it's not obvious. Then I would like to present the common vulnerabilities from the last years from the security conferences and research papers on security. Next point is about the cryptography. I would like to say how to define what the kind of cryptography is required for the particular product, particular solution. We'll also say something about secure product development lifecycle. That's a process that applies to the old technologies. At the end of the presentation, I will present some handy tools that could help you with assessment of the vulnerabilities and creating the threat models. At the last point, I will share some insights about the security challenges that we are facing now, and probably we will face in the next years. So let's start with the small exercise. I would like to engage you in some mental exercise. Let's consider this system that is presented on this slide. So we've got some server. It's a computer network, right? We've got the server inside the system that is connected through the router to the internet. We've got some printer that is connected and some host that is connected through the switch. And my question to you that you can get and do the answer using the poll. The question for you is, what's your proposal how to protect the system? Please try to provide the answer.
Okay, so can you I'll take control there, Marek, and I'll just share the poll responses.
Yeah.
Okay, and so there's can everyone see the screen there? That there's the responses there. So are coming through. So if you want to respond, you can click on join.slido.com. You can use the number there, the code 631936, or you can use the QR code there as well to you can use the QR code to join the poll as well. So please do get engaged. The link is also in the chat window as well if you just want to click on the link, or you can use your phone with the QR code. Okay, so that's interesting. So partitioning the network definitely seems to be coming out on top of the rankings. There's we've finally got a few don't knows there joining the list as well, and the addition of a firewall definitely seems to be quite prominent amongst the responses there as well, Marek.
Yeah.
Okay. So I'll hand back to you. So
yeah.
So feel free to take control there. So again.
Okay, take control. So guys, thanks for your answers. Frankly speaking, I expected this kind of answers. Maybe it will be surprising for you what I will say now, but the good answer is the only one, and this answer is don't know. Why? Because we don't know what's the really purpose of the system. And depending on the purpose of the system and his architecture, what are the rules of all these components, it depends what's the optimal and secure configuration. Let's assume that that's the, for example, banking system, right? And bank accounts are stored and operations are done on the server, right? Then the goal for the security protection of this system is to provide some authentication, isolation between the accounts to not allow to the attacker to change to move some money from one account to the second one. Additionally, we will want to provide confidentiality of the accounts, right? But if, for example, we will imagine that that's the stock market system that is presenting the current stock price, right? Then we will have completely different requirements, right? The stock price should be presented to anybody, but then we need to provide the guarantee that nobody is able to modify the current stock price, because it could, be some kind of speculation and could force the victim to do the unoptimal operations, right? Additionally, probably we would like to provide some solution that will allow to the user from the internet to be sure that he is looking at the trusted page. So the message from this exercise is that we need to understand the purpose of the system, the expected behavior, and the assets that we are going to protect in this system, and what should be considered as attack. Without this knowledge, it's impossible to create optimal protection that is valid for the system. The answers that you provided are completely aligned with the exercises that I'm doing with the students at the beginning of my security lecture. So it's not surprising for me. Thank you for your engagement. I really appreciate it. Let's go to the next slide. So to address this problem, how to implement the optimal and set of security features and secure configuration of the system, the security by design concept was introduced. This concept says that we shall consider all the security aspects just from the beginning of the project through all the product lifecycle, right? So you should talk with your customer about his expected use cases, what shall be considered as a malicious activity, what is a regular behavior. Then it's expected that some security requirements will be defined before any engineering work will be started. Then the vulnerability assessment is needed, and the way to find it, the solution how to mitigate this. This cycle shall be repeated through all the project life cycle, just during the planning, development, validation, deployment, and when the product is in the field. Using this methodology, you can achieve the optimal security architecture that supports all the functionalities with the lower cost. So I would like also to bring to you the non-IT example. So there is a known case of the car wheels theft, right? The good rims are expensive, so some thefts are just unscrewing that and just running away to sell it on the eBay or on the market, right? And that's the issue that is in many countries. So the screw manufacturers started to produce some dedicated screws that cannot be unscrewed with the ordinary wrench. So you need some additional caps that fits to this screws. So the manufacturer sells 4 screws in the package plus the cap, and it's expected that as a customer you will swap one screw in each for each wheel with those secure ones. So attacker will not be able to unscrew this one bolt and will not be able to tap your car wheel. So sounds reasonable, right? But if let's look at some functional limitations that comes with this solution. Let's assume that you are driving and you are getting puncture. If you don't have this cap with you, you need to tow your car. That is expensive and problematic, right? If you would be able to unscrew your wheel yourself, you could just swap to the backup wheel, right? If you don't have a cap with you for some reasons, you have a problem. But what is more interesting, this solution brings also some new threats that are really dangerous and could you know be non-secure, non-safe from the drivers and passengers' lives perspective. Let's assume that I'm going to the dinner to the downtown, and I park my car in the dark street in the evening, and some theft comes to steal my wheels, right? And he tries to unscrew first bolt, succeed, second, third, fourth goes well because it's regular bolts, and finally he has a problem with the last one. After a couple of seconds, he understands that there is a secure screw and he's not able to unscrew this, right? So he just runs away. Okay, that's the most probable scenario. When I'm coming back to my car after dinner, I see that my car is here. 4 wheels are in place, right? And I'm just driving away, right? So completely not aware that one of my wheels is screwed only with the one bolt, right? So it's danger for my life and my passengers, right? So you can see that some kind of solution that tries to address particular security case after the product was introduced to the market could limit the functionality. You cannot swap your wheel without the cap, and additionally can bring new vulnerabilities. If this case would be recognized, identified, and addressed during the design process of the car, of the wheels, of the bolts, it would be easier and cheaper to address this case more successfully. We've got also many cases from IT world. I had a really big problem to choose a couple, right? But I tried to find the most representative. First is a smart keyboard. That's the software solution that came to our smartphones 3 or 4 years ago. The intention of this solution is to help us with the typing on the smartphone. So there is artificial intelligence that tries to give us a hint during the typing, right? So the solution tries to predict what we are going to type. Sounds really helpful, especially on the smartphone's keyboard that is not too big, not too handy. But after some time, security researchers started looking at this, and they figured out that most solutions are based really on the artificial intelligence, but during the learning process, this artificial intelligence uses the collected words that you typed previously, and then sends the set of these words to the cloud, and performs the training of the artificial intelligence, right? So where is the problem? The problem is that this cloud is not protected well because nobody identified this as critical for security. And the second problem is that that smartphone sends all the words that you typed, including your passwords. So it's really scary because in the cloud of the third party, there is a set of all words that you typed, including your password. So it's really easy to perform the brute force attack using the dictionary that was sent to train the neural networks, right? And this vulnerability were found in many implementation of the smart keyboard for the smartphone. I think you heard about it. The second threat that I would like to mention was disclosed on the Black Hat 2018. I was on this conference in Las Vegas. So the presenter shown the live demo how he is able to overtake the accounts for the all top social media platforms. The only assumption was that victim cannot have an access at the moment of the attack to the mobile network. His scenario and idea for attack was really simple. When the victim has no access to the mobile network, then attacker starts to trigger the password recovery procedure, and he is choosing option by the phone. So this option works this way that the system calls to the account owner, right? But if you are out of the mobile network, then the voicemail is enabled, right? So the critical message is recorded to the voicemail. In the US, it's really simple to get the password to the voicemail, because it's combination of the initial set of the numbers that is related to the operator. So each operator has his own set of starting numbers, and the last numbers are just number of your phone, right? So it's really easy to guess. And then attacker calls to your voicemail, gets the secret, right, and changes the password to get ownership of the victim's account. So it sounds really simple. And he presented this during presentation on 3 or 4 top social media platforms, right? You can say it, Marek, but some of the services are free, some are use consumer electronics. Maybe for more solid solution, it's better. For some, yes. For some, no. The last thread that I would like to present is related to the airplanes. Also on the Black Hat, some security researcher from Israel presented the thread that is related to the SATCOM. That's the technology that allows for the satellite communication, for example, to provide the internet to the passengers. So this researcher just take a flight, 40 minutes flight in the Europe, from one country to second country, and the plane operator provided internet to the customers, to the passengers, right? So regular case, and he just sit in the airplane started, and he just checked his email, and he was bored, right? So he started to using Nmap to recognize, oh, what interesting devices are in the Wi-Fi network, and he saw some smartphones, some laptops of the another passengers. That is not surprising. And finally, he found a transponder, right, that provides the internet to them. And he identified using the name that it was presented on the network, the model, the manufacturer. He visited a website of this customer, and he found there firmware update image for this device. So as security researcher, he found it's really interesting. He downloaded the new firmware and he edited this with the just hex editor to see what is in the binary. And he found in the plain text the default configuration login and password. So he got this login and password, and he was able to log in to those transponder in this plane, right? So sounds scary. And he was able to change the position of the antenna that was used to provide the internet to the passengers, and he was able just to move this antenna, and he lost communication. So it's really scary, right? We expect that for this kind of the system, it should not happen, right? So you can see that even in the solid state mission critical systems, there are vulnerabilities, and we shall be aware of the security aspect when we are providing our products, our services. So you can ask, but what the attackers do, right? How they are looking for vulnerabilities and how they can succeed, because it's not obvious. You are buying a product, you are taking it from the package, and it's not obvious where is the vulnerability. So I read some papers. I talked to the ethical hackers, and I collected on the slide the list of the main vectors that they are checking when they are looking for vulnerabilities. So first thing that we need to remember is that there is an unfair advantage, right, between the attackers and the guys who are designing and protecting the system. When you are a designer, architect, developer, you need to protect all the potential gaps, all cases, all flows. The attacker just needs to find the one vulnerabilities for the most cases, just to jump into the system and achieve his goal. The another thing is that the project has a limited time. So there is a time of planning, of architecture, development, validation, deployment, and sustaining when the product is in the field, right? And attacker can spend a lot of time observing the system, observing the traffic, the behavior. He can buy many samples of your product. He can assemble this. He can modify some things. He can overhear the traffic on the buses. He can swap some elements, connect to the sniffers. So these days he has a really powerful tools with the low price that could figure out how the system works and where he could find the vulnerabilities. The second vector is publicly available documents like documentation, like patents, like reverse engineering tools that are available in the internet, like sharing knowledge on the forums with another security guys. For example, if you are tracking the releases of the software or firmware for your product that you would like to attack, you can see some differences. You can see where are the differences in the binary files. You can see what was fixed in the release notes. So you can observe the changes, and you can expect that some of them maybe are not implemented correctly. Maybe there are some vulnerabilities around the latest changes. There is also another thing that are practiced by the hackers. It's to snoop around the legacy code. Because, for example, if the manufacturer releases first generation, second generation of the, let's say, smartwatch, some functions probably will be ported from the first generation to the second one. And attackers expect that maybe this porting is not fully successful, probably the old code is not maintained carefully, so something could be there, right? So there are two flavors to look at the new changes and the legacy code that is not changed. You should also remember that when you are providing the product, this product can be targeted as a target. You can be targeted as a victim, but you can also be considered as a vehicle to attack another device or the system. The good example for this scenario is IP webcams. IP webcam is a really powerful tool, right? It's in the most cases, webcams has a good power supply conditions because it's supplied from the regular electricity network. Has a broadband internet connection because it's intended to stream the video in the real time. Has a pretty strong processor that could execute many operations because video processing could be consume a lot of computing power. So we can see in the articles in the internet many cases when the webcams were owned by the hackers, and the group of the webcams were used to perform denial of service attack for some websites and other systems. So they wanted to use these powerful webcams with good power supply and broadband access to the internet to generate many requests that will just shut down some services, right? The last thing that I wanted to mention at this slide is zero-day vulnerabilities. We've got two types of the hackers, right? One is white hats. That's the guys who wants to make a world more secure, and they are looking for vulnerabilities. Then they are submitting this back to the manufacturer, producer. They're helping to fix the vulnerability to make world more secure. And these days are many bug bounty programs that give them the money, right? Like a bonus for making their product more secure. And for the most cases, the vulnerability is publicly disclosed after the product is fixed, and that's fine, right? Because when it's disclosed, then this vulnerability is no longer available, and customers are secure, right? There is also the group of the black hats, so non-ethical hackers that finds vulnerabilities, and they are selling these vulnerabilities on the black market, right? So it's used by unethical attackers, and the problem is that this 0 days can be undisclosed for a very long time, for the years, right? Till it's not publicly available, publicly known vulnerability, the security systems like antivirus software, like IDSs, like some intrusion detection systems cannot recognize this attack because they are not aware of this, right? So it's really challenging these days to protect the system against 0 days attacks, and so if it's a good practice, if some external security researcher will submit to you the bug, is good practice to work with him to try to understand what he found, to decide is it a real vulnerability, and try to address it. Work with him to show the interest for his submission, right? Then probably he will be able to help you and disclose this bug after it will be fixed, right? That will be crucial for your reputation and your clients, right? On these slides, I would like to present the typical vulnerabilities from the last year from the security conferences and papers. First is unauthorized access to secrets and data that are stored in the system or used by the system. The good example is the last attack in the Ireland for the medical system, when this kind of protection was broken, and there is a huge problem with the medical systems, right? So what we are experiencing in the Ireland now. I heard about this kind of attacks for years in the US for the power delivery systems. And so looks like the density of this kind of malicious activity is growing. The second is ability to modify the system configuration, to change the configuration to achieve the attacker's goals. So it's a kind of privilege escalation, and this point is valid for the web services, for the software, for the embedded systems, IoT, and let's say even SCADA systems. Unsecure key exchange protocol, and additionally unsecured way of the storing the key passwords. That's those case with the SATCOM example that I presented. Lack of authentication. During the conferences, I saw many attacks, let's say for the self-driving cars, right? When the attacker was able to force the system to execute malicious firmware without authentication, integrity, validation, and things like this. So cryptography was really strong to protect the data, but nobody thought about protecting the firmware and firmware update procedures. So malicious firmware was able to harm the system. Next thing is possibility of impersonating trusted equipment. So let's imagine that you've got energy counter or water meter that is electronic, and somebody could impersonate it to let's say modify the readings from this sensor. The same thing applies to the automotive when attacker is able to mimic the sensor to modify the parameters of the driving. It happened 2 years ago for I know two main manufacturers. Many videos are on the YouTube when the security researchers shows how they modifies the reading from the sensors in the self-driving cars. Last but not least is a privacy violation. Some systems doesn't take care of the user privacy, so it's possible to track the user and to disclose some secrets. The very interesting case were disclosed by U.S. Army 2 or 3 years ago, when the soldiers tried to they were using some fitness app in their smartphones in the hidden database on the desert, and they were running with this application around the data around the military base, right? So on the map of the users of the tracks were publicly available to everyone, and security researchers found the locations of the secret military bases of the U.S. Army, because they found the rounds of running men's in the morning and in the evening each day in the middle of the desert. That was, not regular case. Some words about the cryptography, because cryptography is known as a solid pillar of the security. It's true, but I would like to say that you need to be aware of how to define what kind of cryptography and what is the required strength of the cryptography that you need for your solution. So when you are considering what kind of cryptography shall be used, first of all, you need to understand what's your use case. How many data you will exchange, what shall be protected, what's the size of this data, and how this cryptography will be used. The second is application that will use this cryptography, because some special use cases like self-driving cars, like medical solutions, like government solution, require specific norms, needs to meet specific standards for the security and algorithm that needs to be implemented for these products, right? So some of them will be defined by the standards. Finally, you need to consider the expected lifetime of the platform, right? If you are designing the smartphone and you expect that it will be on the market 2, 3, 4, 5 years, you need to extrapolate the cryptographic security of cryptography algorithms for the 5 years to be sure that at the end of the lifetime of your product, your clients will be secure, right? But if you are planning to deploy some manufacturing system that will be deployed for the 20 years, you need to think what will be in the 20 years. You need to figure out what kind of algorithms will be secure in 20 years and to apply them. There are also some standards. Let's say many of them are published by NIST, that's the US Standardization Committee, and ISO, European one, that says till, let's say, 2031, these algorithms are considered as secure, right? Later, you need to improve your strengths of your cryptography to this, and this. So it's good to understand how long your product will be used, and to do this kind of protection. It's also important to understand how the cryptography shall be used. I saw many cases and many bugs in commercial products when the very strong cryptography used in the wrong way caused the very big vulnerabilities that were very easy to exploit, right? So it's crucial to understand how the cryptography works and what are the assumptions that makes this cryptography secure and how to use it. I would like to also note that at the universities there are many departments provides the courses about the cryptography, right? And there are some lectures, some labs, some projects, and many of them, I also was involved in this kind of activities. Students are asked to implement some cryptography. It's great for educational purposes, so to young engineer to understand how this cryptography works, where is the and how complex are these algorithms, how this is implemented. So that's great for the educational approach, right? But for the commercial use, when you are providing the solution that will be in your real product, it's not a good idea to implement cryptography yourself. It's not a good idea to invent cryptographic algorithms yourself, and it's even not a good idea to implement well-known standard yourself. Why? Because the problem in implementation, the bug in implementation, can make this implementation non-secure. There are many cryptographic libraries that are open source with good licensing models that could be reused, and it's maintained by the community. So even if some security researcher will find some vulnerability, community will fix it immediately, and then you could just to pull this new version and to use it in your product. The same applies for the commercial implementation. So it's cheaper and more secure to use the external implementation that are done by the wider forum. At Intel, we've got a very limited set of people that are very highly skilled that can review and potentially modify some details in cryptographic algorithms. There is a very limited set of people. So it says that even in the big company like Intel, we are very careful with the cryptography implementation. The security validation. This process shall be also part of the regular software product development lifecycle process. On the right side, you've got the chart that presents what's the dependency between the cost of the bug fix and the time, right? If you will find the vulnerability at the requirements level stage, right? Probably it will end with some changes in the records in the database where the requirements are maintained, maybe some discussions, but not too much in terms of the cost. If it will be designed phase. Additionally, probably you will need to call some meetings with additional guys who is implementing this. So not too much, but more effort than at the requirement stage. And you can see that with the time, the cost grows significantly, right? The problem is when you've got implemented everything and some basic bug in the concept or requirements will be detected, right? The real problem is when the product was released and you are not able to fix the product in the field. So there is an option that you will need to call your clients to return your parts, fix and ship it again, right? So it's really costly, and you are losing some reputation, right, to the clients.